Hey guys, it's Surya and today is Monday, which means it's time for another tutorial. Today I'm going to be teaching you how to solve this cube in brief. I made a full explained tutorial last week. Now this cube is a shape modification of the Pyraminx, but you don't need to know how to solve the Pyraminx to do this. You also don't need to know any cube notations. Why that's the case, I'll explain in a bit. So hope you enjoy the video. So before we get into how to solve this, let's just understand how it works. So these corners don't really rotate. I hoped they would when I bought this, but they don't. Instead, this whole thing does. And whenever you take one of these pieces and rotate them, it takes 3 rotations to bring it back to its original state, which is unusual since there's 4 sides. Now, if you were to analyze this cube in more depth, which I've done in my full-length tutorial, you will see that these pieces, these 4, the ones which I have my finger on, they never move relative to each other no matter how you rotate it. See that? They all 3 rotate, but that doesn't really count because they're still in the same order. So so these 4 are always in the same place relative to each other, and the other 4 are always in the same place relative to each other. These centers keep moving around, they're pretty shifty, but that's how the corners are. So in that respect, it is a shape mod of the Pyraminx, although you don't really need to know how to solve the Pyraminx to do this. In fact, you only need to know one algorithm. It's called the sledgehammer. I will just be representing it with S in brackets, but that's not really the actual notation. Okay, I just made that up to make things easier. So here's how you do it. So you go with any side. Okay, I'm just gonna pick this side to explain it. So here's what you do. You first rotate this side down, pivoting around this piece, this side down, and then this side down, pivoting around this piece, this side up, around this piece again, and this side up, around this piece. So that's just it. That's the sledgehammer. And that is surprisingly the only algorithm you need to know how to solve. You need to know in order to solve this. Now, usually I just hold it in a slightly different way to do it a bit faster, but you don't need to do that. But if you're still curious, here you go. You just hold these 3 sides with your left hand, your thumb in the bottom layer, index finger on the left side, and middle finger behind, just like this. And now you hold your thumb in the front side, your right thumb, index finger like this on the top, and you just use your middle finger on the side, middle finger and the rest of the fingers, you just use it to support. So here's what you do. Just rotate this down. Now push your index finger forward like that. Now rotate this piece up and rotate this back. So you can do that to do it like a bit faster, and it gets a bit easier with that. So now that we know that algorithm, let's get into how to solve it. So the cube looks jumbled. Now, even though these centers are really shifty, we're going to start with the white layer, and we're going to use the white center as reference. I know they're really shifty, but still, let's just use that. So now we just need to solve one corner first, one of these pieces. So we can just do that. For that, let's just see what happens when we make a move. So we obviously can't rotate one of these because it changes this, which means that we can only pivot these lower corners. We can never rotate these upper corners, right? So let's see what happens whenever we rotate some lower corner. So let's start with this one. Okay, so we have a white that's on the opposite side. First, let's pivot it this way and see if it gets solved, and then this way if it gets solved. Although we don't need to do this way because it's symmetric. It being down makes it pretty symmetrical. So if it comes at a certain result on one side, it's just going to be the mirror image on the other side. I'll explain what I mean. So let's first rotate it here. It did not solve, which means that if we have a white on the bottom layer, we need to first twist that into a different position and then solve it. We could just test it here as well just to be sure. It does not work. So let's twist it into the next position, which is here. Here, let's try to bring it over here. So if we do it closely, you'll see that it does not solve. Instead, you see that this piece goes into place. Now let's try it on this side. It does solve. So if we ever need a piece to go, say here, we need to start it from here. It needs to go that way. Seems pretty counterintuitive, but yeah. So now let's start by solving two opposite corners, and then we'll do the other two. So let's start with this one. This, you can do any one. So this one's a blue and an orange. We need to find a red and a green. It's in its place but twisted. So first we need to move it out of its place. We can twist it here or here, anything's fine. I'm going to do it over here. Now we need to twist it in the right way and then put it back. So it needs to go there, which means that the white should be here. So let's just twist it and bring it there. That one solved. Coincidentally, this one also happened to be solved, but I'll just show you what happens if it's not twisted correctly. Hang on. Yeah. So let's assume we have this piece over here. In fact, why here? Let's assume it's somewhere else. Over here, say. It's over here, and it needs to go there. If we try to rotate it like this, it doesn't go in. So here's what we do. We rotate it this way, moving this piece out of place, but it's over here. It's out of the way. Now we bring this piece in, and we bring this back. So this one's unaffected. Of course, sometimes you may need to do it multiple times. For example, if we have a piece like this, it looks like this on the bottom layer. You may have to rotate it once, bring it there, bring it back. It's twisted. So do the same thing again. Bring it down here, rotate it, bring this back, and bring this up. You always need to rotate this piece away from the next piece's position. So you can never rotate this in this direction. Because if you were to rotate it in this direction and move the piece in there, this piece would be twisted out. It wouldn't be twisted right anymore, and you would affect the solving. So let's not do that. Let's do the last one. This needs to go over there. Let's twist it away from where it needs to go. Bring it in place, bring this back. Let's try it again, one more time. And that's it. That's the first layer. Now let's go into solving these yellow corners. Now, luckily for the yellow corners, there are only two situations that you need to remember. The first one looks like this. This is the farthest situation that you can get. It's farthest from its solved state for the corners. Don't look at this yellow center. They keep moving around, as I said. So the first one looks like this. It's where we have two opposite corners up. So in that situation, you keep one of these corners on your far right and the other one at your near left. And you need to keep it in a way such that you can see a yellow here. So you cannot keep it here because there's no yellow here. You need it here. And you do the sledgehammer once. That brings us to the next situation, which looks like this. No yellow at all. I know it looks like we've regressed, but we have not. Now we just need to go to one place where we see only one yellow on the left. So that's over here. Just ignore this. And let's do the sledgehammer. And that solves this. I mean, the center got solved, but that was unintentional. So now that we've done that, let's go into rearranging these centers. Now when solving the centers, the fundamental thing is to use the sledgehammer 3 times. Let's just use it and see what happens. And by the way, it's fine if the white center gets affected once in a while. We can just rearrange it. The good thing is that all the corners are in place. So yeah, let's just do this 3 times. So this is what happens once you do it thrice. These two are unaffected. When you hold it like this, bottom and back layer are unaffected. These two centers are switched and these two are switched. So we can use that to our advantage. If we ever get a situation like this, where we have two opposite centers switched and two adjacent over here switched, we can just hold the cube like this and do the sledgehammer thrice. So that's the first situation we can get. Now the rest of the situations, all of them, are just all about using the sledgehammer 3 times, just using this one concept in different ways to your advantage. So let's just go over another situation. Let's say we have something like this. Something that looks like this, where we have these two sides solved, but we have something that looks like this, where these two need to be switched and these two need to be switched. So in that situation, we can just hold the cube like this, do the sledgehammer thrice. That would switch these two and these two. Now these two would be solved, so we can keep the cube like this and do the sledgehammer thrice. So these two would get switched back, solving them, and we would solve these. Let's just try that. Sledgehammer 3 times. These two got switched. So did these two. Now we've reached a familiar state. Let's get to this. So that's how you do it. Now there are lots of situations, but I'm not going to go over all of them because all of them are just about using this one concept in different ways in different places. So I'm just going to go over two more pretty important concepts and then we'll stop. So here's something pretty important. It's where we have three solved centers like this and three centers which have been mixed like this. This center needs to go there, this needs to go there, and that needs to go all the way here. So in that state, what we could do is first switch, say, these two, switching these, and then we could switch these two, switching these back. So that would mean doing the sledgehammer thrice here, and then turning the cube around, sledgehammer thrice here. But we've got a shortcut. And this situation is a bit of a special one. Here, we don't need to do the sledgehammer thrice. We can just do it once on each side. I'll show you what that means. So we go here, we go to a place where this center here needs to go here. So we can't go here because this center, which is orange, does not need to go to the red side. So we keep these solved centers like this, and we go here. The center needs to go there. We do the sledgehammer once, and then we turn the cube around, and we do the sledgehammer one more time. So there you go. That's a bit of a unique situation. Otherwise, it's basically got the same intuitive concept. Now let's go over a bit of a confusing situation. I'll figure it out along with you guys. Here's a complicated situation. Now I'm sure in an advanced method there are algorithms for this, but in beginner's method, let's just try to use the sledgehammer 3 times each time to solve this. I don't know the algorithm for this, so I'm figuring this out with you guys. So let's do it. So first we see two pieces over here that need to be switched. So let's hold it like this and try to do the sledgehammer thrice. So that solved these. It's moved the rest of the centers in a weird way. Let's see what we have now. Okay, we've reached a familiar situation. We've got these three centers that need to be moved this way. So let's go here, where this center needs to go here. Sledgehammer once. And turn the cube around. Sledgehammer once. And there you go. We've solved this cube. So congratulations, you've solved it. Hope you had fun doing this.